Okay, here's the second part of day 1 for 4.1. And the main concept is if you have a root with a fraction in it, okay, a root with some sort of fraction in it, we can put we can separate the root into a top and a bottom root and then treat them individually because we don't really like fractions. So, and the nice thing about that too is the other way goes. So we can put them together or we can take them apart as long as the root is the same size. So here's an example where this comes in handy, where it's nice, is if we take this and write it as the square root of 15 over the square root of 64, 15 breaks up to 3 and 5, so we can't simplify it, but 64 breaks up to 8 and 8, so we can rewrite this as the square root of 15, because that can't be simplified, over 8. And we like it when there's not a fraction on the bottom. Okay? B, same thing, is we like this because we can rewrite it as the square root of 81 over the square root of x squared. And 81 is 9 times 9. And I have buddies, so I can just take them out as a 9. And this is x times x. So then this equals 9 on top and just the x on bottom because they come out as 1. Okay? Then we're going to continue. The cool thing about this is these properties work no matter what root size it is. So for example, we've got a couple of examples, okay, where these are cube roots. So in cube roots is where n equals 3. So the only thing that's going to be different is instead of circling them in buddies, we're going to circle them in groups of 3. So I'm going to focus on this first one. I'm going to factor and make a factor tree of 128. And I don't know what 128 is, okay, but 128 is even. So I'm going to divide it by 2. Oh, and I get 64. So I know it's 2 and 64. And 64 is 8 times 8, where we get 2 times 4, which is 2 times 2. And then 8 is 2 times 4, which is 2 times 2. So I'm going to circle them in groups of 3. So I've got a group of 3 there and a group of 3 there. So when they come out, it's 2 times 2, because I've got 2 groups of 2, cube root of just this 2 that's left over. Okay, so this is 4 cube roots of 2. Okay. Example B is a little bit different, but the nice thing is, here's an example. If you have a negative and your root is odd, the negative automatically comes out. Okay, so I know that negative is going to come out, and 125 is 5 times 25, which is 5 times 5, so there's a group of 3. And x to the 7th, you can write them out 7 times and circle them in groups of 3, or you can do division and say how many groups of 3 go into 7, and there's 2 and 1 left over. So what I take out is I take out the negative sign, a group of 5s, 2 groups of x's, and then what's left is just that one x that's left over. So I get negative 5x squared cube root of x. Okay. Example C, we're going to use some of the properties that we've already talked about. This is the same thing as the cube root of y over the cube root of 216. And the cube root of y is not going to simplify, but 16 is 6 times 36, which is 6 times 6, and I get 3 6's. So the best answer is y over 6. Okay, and here's the last one, and it looks kind of messy, but don't panic, because the process is still the same. The only thing that's different is our factor tree just gets a little bit bigger. So I'm going to do the top by itself, okay, and then the bottom by itself. I'm going to make factor trees for this. So 8 is 2 times 4, and 4 is 2 times 2. I've got 3 2's, and I have 4 x's, but I can only bring 3 of them out. So on top, I've got a group of 2, a group of x's, and then left on the inside is that 1x right there. And then on bottom, 27 is 3 times 9, which is 3 times 3. So there's a group of 3's, and then 3 y's, so I get 3y. okay? When nothing's left inside, you don't have to do the signs again, okay? So, for the next part, I want you to pause the video and then try the next problems on the next page. And then I'm gonna, if you need to check, there's gonna be another video that you can use the next video to check those answers. I'll go through those thoroughly.